All right, welcome back to another Mathtastic episode with me, Mr. D. We're working tonight on evaluating a logarithmic expression with or without a calculator. All right, so we see these oftentimes. We have these logarithmic expressions, easy for me to say, right? And we need to deal with them. We need to figure out, well, what are they looking for? So in some cases, we can use it without a calculator, and in other cases, we need a calculator. So what we can do is, again, let's review what a logarithmic equation looks like. We have something that says y equals log base b of x, and an exponential equation that is base b of y equals x. So this is the exponential version of this logarithmic function. Now, in some cases, when we want to use our GDC or graphing display calculator, otherwise known as a regular calculator, we will use that instrument in order to help us find it, because sometimes we don't know exactly what it is, and we're pretty smart, but we're not always that smart. So we rely on a machine every once in a while. Okay, so let's look at what we have here. Let's look at some examples. Here we have log 2 of 64. So this is really equal to y, right? So what are these y values? And so we can rewrite this as, let me come over here, rewrite this as 2, all right, we'll use base 2, 2 to the y, 2 to the y is equal to 64, is equal to 64. So, and so we can figure out what y is from that. We can also look at, well, let's see, 2 to the third power would be 8, 2 to the fourth power would be 16, 2 to the fifth power would be 32, 2 to the sixth power is 64. So 2 to the sixth, so y then is equal to 6. Y is equal to 6. Okay? All right. The next one, it says 3 to the what power is 1 over 27? Well, we have a multiple of 3 here, so let's rewrite it as 3 to the y, 3 to the y is equal to 1 over 27. So we write 1 over 27. All right, 1 over 27. Now, we can also think of 1 over 27 in terms of 3. So if I just take 3 times 3 times 3, or 3 cubed, that would be 27. So what I'm going to do is I'm going to exchange that 27 for 3 to the third power. And now, since it's in this form, what I can do is I can say, oh, well, that's just 3 to the negative 1 power, or a negative 3 power. So we get 3 to the negative 3. So this is 3 to the negative 3. So we find out that y is equal to negative 3. So y in this case, y is equal to negative 3. All right, last one. Now this one's written kind of interestingly. It has a big 3 here, and then all to the power, it says log 3 of 18 is equal to y. Well, when we have things written this way, we can just, there is a rule, logarithmic property, that says if you have the same base, then basically these two agree with each other, and so 18 is equal to y. So y is just 18. And there's our answer for that one. One final one. If we have ln of the square root of e, well then we can write ln of e to the 1/2 power exponentially. And we know that anytime we have ln of e together, then that means they go away and we are left with 1/2. So that would be our answer there. All right, now let's take a look at some where we need a calculator. So these are evaluate each logarithm expression with your calculator or your GDC graphing display calculator. All right, so check it out. We've got log 2 of 13. Now, I don't know about you, but when I have to ask myself, 2 to what power is 13? Well, 2 to the third is 8. And then all of a sudden, 2 to the fourth, well, that's 16. So 13 is somewhere in between 3 and 4, but I don't know exactly where. I don't have it in my brain yet. I don't have that memorized. Well, maybe one day, but not right now. I have too many other things to think about. So I'm going to rely on the old calculator because it's a good friend of mine. We like it. And so here we go. Let's move this over a little bit so you can see everything. If I use the change of base formula, that means we are going to take log of the upper portion here and put that in the numerator, right? And then log of the base, right, in the denominator. Then I take log 13 divided by log 2, and we get 3.7. So right there, we knew it was between 3 and 4, and we knew it was closer to 4 than it was to 3, but we just didn't know exactly. So there you have it. That's straight out of the calculator. All right, log base 3 of the square root of 5. Again, I'm not sure what that is, so I'm going to put that in my calculator. Now remember, with the log properties, this would be log 5 to the 1/2. You can put in your calculator as the square root of 5, but you can also bring this down and say 1/2 log 5 divided by log 3, and either way, you'll get 0.732. All right, so now we have ln of the square root of 3. Ln, that can be rewritten as ln 3 to the 1/2 power. We bring the 1/2 down, so we take 0.5 times ln of 3, and we get 0.549. All right, so that is looking at logarithmic equations, evaluating them at a certain numbers, with or without your calculator. And that's D. Dykstra. I'm out. Math that like button. Thanks again. Have a great night.